Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The American Southwest is an ideal testing ground for the hypotheses of electric universe geology. Geological textbooks tell us that the hallmark, breathtaking features of these desert regions formed through slow, erosional processes over eons of time. But laboratory experiments with electrical discharges have opened new theoretical pathways that inquirers in increasing numbers around the world are following. A remarkable contributor to the burgeoning field of EU geology is Thunderbolt's colleague Andrew Hall, whose articles and video presentations have explored new electrical interpretations of desert geology. In part one of his three-part presentation, Hall presents his detailed analysis of the stunning features in Canyonlands, a dramatic desert landscape in Utah, beginning with a discussion of the amazing formations called the Arches.
In summer of 2016, following the EU conference in Phoenix, Arizona, EU geology researchers visited Arches National Monument in the deep reaches of Canyonlands, Utah, where the Green and Colorado rivers channel through the Colorado Researchers visited Arches National. Arches National Monument is an astonishing place for anyone interested in EU geology. By conventional reckoning, the high desert plateau was carved into fantastical arches and hoodoos after millions of years of subtle water and wind erosion. To the EU researchers, however, it was evident the land was zapped, carved, and seared by electrical storms that could have happened last year. So fresh looked the marks of evidence. The Arches formation tells a story which explains one of the key phenomena that shaped the face of the planet. The phenomena is called sputtering discharge. So let's take a look at what that is. Sputtering discharge, as used in manufacturing, is a dark to glow mode current in plasma used to deposit thin films of material onto a substrate surface. It's analogous to electroplating or galvanic reaction in a fluid. An electric field accelerates positive ions in plasma to collide with the source material, which breaks molecular bonds, eroding the source material. This is what the term sputter refers to, breaking away of particles in the source material, which then drift in an electric field to coat the substrate. The source material is the cathode, and the substrate is the anode in the circuit. The material exchange is performed by electricity. Manufacturers often use magnetrons to shape and control the current and improve material transport efficiency with external magnetic fields.
We were invited to Quebec.
And we disconnected from social media so we could really connect with this beautiful place.
It's pretty wild here.
Material transport efficiency with external magnetic fields. The point to be made, however, is that high voltage, low current in a plasma will erode or etch away a cathodic surface and plate itself in layers on the anodic surface. This is the process that shaped Canyonlands. To fully understand these canyons, however, first we must understand domes, because the canyons are carved from a dome. The entire Colorado Plateau is a dome, or rather a series of domes, overlaying each other. The domes are composed of sedimentary layers of limestone and sandstone. The layers are stacked, for the most part, evenly and flat, like a layer cake. The basic layer cake structure is capped with the Rocky Mountains on the east and carved into canyons on the west, while it's shot through with the Lichtenberg patterned, vertically cut gorges of the Colorado and Green rivers. The dome structure of the plateau and the canyons carved through it is primarily the result of natural sputtering discharge process created during an intense electrical storms. Of course, in this case, we're speaking about storms created in a past environment when Earth's electric field was amplified to the point the entire atmosphere was ionized. Imagine the atmosphere stirred into a maelstrom, lit with streamers of glowing plasma, where lightning crackled not only in the sky but across the land, and mountaintops glowed with coronal fire under swirling clouds of dusty plasma. It would have been surreal, a place where streams of wind became electric currents, where high and low pressure zones acted like battery terminals, and mountaintops became electrodes drawing machine gun lightning from the sky. Anything standing in the wind would have hissed and snapped with coronal fire. Dust in the air would have acted strange, too, as the energy of free electrons collided and overpowered weaker atomic bonds, ionizing matter, causing it to act like a ferrofluid under the influence of a magnet. Ionic species segregated, forming unipolar winds that tore past each other in opposite directions, creating shear zones of intense electrical discharge and vortex winds of supersonic speed. The inside of Earth would have been in turmoil as well. Hot magma spewing from volcanic vents, aquifers boiling, explosive eruptions of steam from deep underground, pocking the landscape with holes. Even arcs would erupt, lightning from the ground, caused by buried pockets of charge where minerals and water ionized. The winds, dust-laden and electric, deposited the Colorado Plateau, plating a cake across the western half of North America in the same way semiconductor manufacturers layer circuitry onto silica wafers. The stratified layers are interspersed with magma flows, petrified forests, inland seas, and dinosaur boneyards of different ages that indicate it formed in a series of events that likely recurred over millions of years. To create the canyon lands, the voltage potential had to reverse and eat away at landscape newly laid down by the storm. Under the electric field of an electrical storm, the surface of the Earth becomes positively charged. It becomes the anode in the circuit where lightning strikes from the negative cloud base and where rain falls. In primordial ionic storms like those that form the plateau, rain did not fall, but silica did, as dust in the air fell and adhered in layers to the dome. Inland seas are layers washed over by tsunami, generated by the storm itself, became covered over with more layers of dry overburden as the storm progressed. This left a moist layer, like icing in the center of the layer cake. This icing layer then ionized under intense bombardment from sputtering discharge in the eye of the storm, and created what is known as barrier discharge in the moist layer beneath the ground. Which brings us back to Arches National Monument, proof that canyons were carved by sputtering discharge, aided by barrier discharge, in a moist layer of the big cake. This image tells most of the story. A band of rock looks tortured and fluid, as if it were boiled mud when it solidified, sandwiched between smooth, more or less even layers of stone. The canyon floor is flat, which is surprising if one accepts the consensus view that canyons were made by water erosion. Water erosion leaves deep channels and V-cut valleys, not flat floors. This closer image shows the fluidity of the layers. At the top, the overburden rock barely sinks into the sagging layer beneath it that turned plastic, because it was still solid. The plastic layer beneath sagged, but didn't compress and maintained a consistent thickness. Below that, on the bottom, the boiled mud layer fluidized completely and squeezed like toothpaste. What turned this bottom layer fluid and caused it to sag beneath a solid overburden was electric current, a barrier discharge current, where no gaseous atmosphere was present to ionize into plasma, but instead the moisture and minerals in the layer ionized, generating a subsurface current. The moist layer ionized and charged species pooled into a plasma-like mud the electric field wanted to lift away. The electric currents boiled the moist layer, and it began to foam and arc into the drier and electrically resistant overburden. When sputtering removed the surrounding overburden, pressure released and vapors expanded, making gas bubbles that raised the arches. Hardened pinnacles formed where mud boiled up and convective blossoms of hot ionization. One can see how the moist layer boiled and heaved, while currents arched and thrust upward, trying to break through the overburdened rock. But in this area it was unsuccessful. The traces of barrier discharge remain in the rock. The empty flat canyon floor, where the overburden and moist layer were carried away, is where the discharge broke through to complete the circuit. Arches is a display of etching, or electric discharge machining, EDM, stopped in process. The wet layer was boiling off due to the current in it and lifting away with the overburden when the process stopped, leaving these arches and hoodoos. It likely stopped when the sputtering glow current suddenly jumped to arc mode and lightning struck, dissipating the charge built up in the wet boiled mud layer. Sputtering discharge is typically used in manufacturing to remove only micrometers of material. The ion bombardment on the surface of cathode material only shallowly penetrates to break atomic or molecular bonds and release particles. So how could such a process remove hundreds of feet of solid sandstone? Well, one reason is the strength of the electric field at work on the charged species. In the primordial storm we are discussing, the electric field would have been billions, perhaps trillions of volts. The electromotive force of such a field applied to any large pool of charged species could lift a mountain. And the other reason is diffusion of charge through 1,000 feet of dry sandstone overburden to ionize the wet layer. The section of the dome overlaying the wet layer acted as a solid-state semiconductor, coherent with the intense electric field. Charge diffused through the silica layers in a manner to be discussed in more detail in Part 2 of this article. But solid-state electronics are the way to evaluate how charge diffused through the landscape. The wet ionized layer then underwent a process called heat spike sputtering. Heat spike sputtering occurs when diffusing ionization causes secondary reactions. The secondary reactions occur in the wet layer, which is highly conductive and volatile. Currents heated the material, and that caused thermal liquefaction, melting, and steam microexplosions. In canyonlands, when the wet layer ionized, it induced currents which heat spiked, discharging from the wet layer to the layer above. The arches and bubble-like pinnacles in Arches National Monument were created by heat spike sputtering and bubbles of microexplosions as the boiled mud layer ionized, vaporized, and discharged into the overburden. This short film, produced by Diefly Fish on YouTube, helps visualize the process of diffusion through rock and the process of barrier discharge that caused the boiled mud layer to boil. In it, Jim Hammond, the creator of Diefly Fish, and an EU contributor, employs a high-voltage Tesla circuit to generate current through a granite block. There are two things to note as you watch the film. First, note how the flow of electricity diffuses through the entire granite block. Instead of channeling directly below the electrode in a narrow stream, like an arc, it flows out the full footprint of the crystalline granite block. The external electric field of the circuit is diffusing charge through the granite as it would in a solid-state body. In the tense electric field surrounding the eye of the hyperstorm that etched the canyons, currents also diffuse through the dome matrix in this way, ultimately ripping out mountains of earth in the blink of an eye as currents boiled and liquefied the wet matrix below, similar to the plasma tornadoes that are swirling in the gaps between the electrodes and granite in the film. Second, note the plasma tornadoes that bridge the gap between the block and electrode. They are not in bright arc mode, but are filaments in glow mode. The plasma tornado currents are in the air gap where the air has ionized to plasma. In the arches, there was no air gap between the ionizing wet layer and the overburden, so the discharge was a barrier discharge coming from the boiled mud. The currents flowed around the boiling, bubbling, foaming heat spikes to fuse and harden the less conductive overburden in its pattern of arches and pinnacles. Jim's experiment demonstrates how current diffuses through granite, which demonstrates how ground currents can diffuse in natural rock. Watch towards the end of the clip. Arcing begins in hot spots to eat through the granite, collecting the current into single arcing paths and starving the diffusion currents around them. There are many other evidences of sputtering discharge in the Utah Canyonlands. In Part 2 of Sputtering Canyons, we'll examine some more. Thank you.
Hey everyone, I just arrived in Quebec. I am completely disconnecting from social media so that I can truly connect.
Examine some more. Thank you.
Hi everyone, I'm Dr. Nancy Lynn. Most people know me as
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In a recent Space News, Thunderblog contributor Jimmy Micketts offered a thought-provoking analysis of an audible phenomenon that has puzzled scientists and laypersons alike for decades: the mysterious so-called hum. As we've described in many episodes, anecdotal accounts dating back centuries describe puzzling sounds associated with electromagnetic. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Of all the entrenched beliefs that took hold, welcome to Space News from the Electric Universe, brought Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In our previous episode, we introduced a potential scientific breakthrough that could have profound implications for all of cosmology, eliminating the perceived need for dark matter. In recent years, retired professor of electrical engineering Dr. Donald Scott has composed an original modeling of the structure of a Birkeland current. The visual signature of the Birkeland current is counter-rotating cylinders, which are clearly seen in the earthly auroras at the north poles of Jupiter and Saturn. And as seen in these recent images, even at the poles of Neptune. In the electric universe, Birkeland currents flow across interplanetary, interstellar, and even intergalactic space, organizing material across the vastest cosmic distances. In a new scientific paper entitled Birkeland Currents in Dark Matter, scheduled for publication in April of this year, Dr. Scott proposes that his model of the Birkeland current may finally help explain anomalous stellar velocity profiles with no need for dark matter. In this episode, Dr. Scott summarizes his new paper, beginning with a review of his previous findings on the Birkeland current structure.
As most people who've seen Space News realize, I was fortunate enough a couple of years ago to develop a model for the so-called Birkeland current. The Birkeland currents, just to bring everybody up to speed, is the shape that the clouds of charges that emanate from, well, one example is that emanate from the sun and that go down into the North Pole and the South Pole of Earth to create the aurora borealis and the aurora australis. That's the Birkeland current. And Birkeland was famous for essentially postulating the existence of those currents, and it was only after World War II that when we sent the United States Navy, I think it was, sent some rockets up there, they found out that Birkeland was right. That's what was powering the aurora. Well, anyway, to make a long story short, the question is nobody ever knew what shape those charges took on. Did they come in a cylinder like a pipeline, or did they sort of diffuse like a fire hose, or what form, what structure, if any, did those charges have as they came through space? My model, which was actually started by a fellow named Lundquist, and I finished the derivation and interpreted what the results meant. And there's a graph that I sent you there. What that is a picture of, if you can visualize it in your mind's eye, this is a picture of what happens to the magnetic field that surrounds the Birkeland current as a function of your distance away from the center line of the Birkeland current. So if you visualize you're standing up in Canada looking at the side of the Alaskan pipeline, let's say, and there's this big pipe in front of you, and it's running from left to right. And the horizontal axis on that graph is the distance your eye is from the center of the pipeline, okay? So as you back away from the center of the pipeline, you're going from left to right on that graph. So at zero, that is to say at the axis of that picture, you're right smack dab in the center of the Birkeland current. And the red curve is a description of the strength of the current density, that is the current flowing down that pipe from left to right, and also the magnetic field, because the magnetic field and the current density are hand in hand, parallel. They go right along together like two twins. And so you can see that at the center, that red curve is a maximum, and it's at 1. And the blue curve is the component of the, let's say, the current density that surrounds, like you were wrapping that pipeline with a tape. Well, that's the direction of the magnetic field and the current density that is shown by the blue curve. There's two vectors. You got one pointing down the pipeline and one pointing around and wrapping around the pipeline. If you add those two vectors, you get the green curve. You can see there's a green curve that sort of starts off at 1 and then it comes down. There's a little bit of a wiggle in around radius 3 or 4, but eventually it hides behind that purple curve. Well, that purple curve is just a plot of, if you look over at the legend on the right-hand side, of the radius to the minus 1/2 power. That is, it's 1 over the square root of the radius. So the purple curve is a plot of 1 over the square root of r. And that's what my model says happens. It says that the current density, if you're in the middle of the pipeline, is quite high. It's very dense. It's a strong current. It's a strong magnetic field. And as you come out, these two different components, the sort of the axial component, the red line, the magnitude is the red curve, and the wraparound, which is the blue curve, that sum varies as that purple curve does. Actually, it's the green curve, but the green curve you can see hides right behind the purple one. So the bottom line of that whole diagram says that the strength of the magnetic field and the current density as a function of radius out from the center of the Birkeland current is given by the radius distance that you're out there, to take the square root of it and 1 over that. And so it decays, and it decays down very slowly, but eventually, it's an infinite distance out, it'll go to 0. About a year ago, I started to think about, what else can I find out about this Birkeland current? The result is, and I won't bore you with the mathematics, but the key that unlocked it for me was the current density in amperes per square meter of going down that pipe is equal to the product of the charge density, that is, how many coulombs per cubic meter have you got inside that pipe, times the velocity of that cubic meter. So visualize you've got a square cube, say a meter on the side. It's got a gazillion and a half electrons in it, or protons or whatever, and it's traveling. It's moving from left to right. Well, that constitutes the current. And my model said, well, we know what that product is. We know what the current density is. So here's the key. If you know what the velocity is, you can tell from that little equation that the current density equals the charge density times the velocity. If you know what the velocity is, you can get the charge density. Or vice versa. If you know what the charge density is, you can get the velocity because you know what the product is. So the question is, well, where do you go from there? Well, there's a lot of talk these days about the fact that these Birkeland currents, huge versions of them, not the kind that just go into the North Pole of Earth, but the kind that actually feed galaxies, are feeding galaxies, and galaxies are forming in strings. Those strings are Birkeland currents. And so we know what the velocity of rotation of those galaxies are. I think I've included a picture there of M33 galaxy, and there's a graph of the velocity in kilometers per second versus the radial distance out from the center of the galaxy. And so I made an assumption. Now, it's a big assumption. It's a big if. But if I'm right, And if Birkeland currents do feed those galaxies, the galaxies form on those Birkeland currents due to the Z-pinch effect, then you can look at that curve and you say, hey, that's the velocity. I know what the velocity is. It begins as the yellow curve from starlight, and it continues on from the 21 centimeter hydrogen data that goes out. But it looks like the velocity goes up very quickly as you move out from the center of the galaxy. And then it doesn't slow down, it keeps getting faster, but it gets faster at a very slower rate. And that's called the stellar velocity profile of a galaxy. And that's been measured for decades. Well, the problem is that the people who looked at that first were Fritz Zwicky and Jan Oort. Looked at these curves, this one's very much like this, and said, oh, that's not what Newton's laws say should happen. On that curve, you see there's a dotted line, and it says this is expected from the visible disk. Well, this is what's expected from Newton's laws. The velocity should get lower with increasing radius, not higher. Well, that was a big puzzlement, and so astronomers at least began to publish papers, and they all settled there's invisible matter out there that's changing the equation, and there's really more mass out there than we thought. If you include this missing invisible, somebody named it dark matter, then that curve will be as we measured it there, that one that continues to increase with radial values. Make a long story short, these guys, these astronomers, have been hunting for this dark matter for 85 years. And there's been experiment after experiment after experiment to try to find the dark matter that gives it that stellar profile of M33, a rational explanation. And they haven't found it. They've come up with strongly self-interacting dark matter, repulsive dark matter, self-annihilating dark matter, fuzzy dark matter. Well, it goes on. It's ridiculous. They don't know why Newton's laws don't work in those galaxies. And there was a fellow by the name of Marty Milgram. He came up with the proposal we have to modify Newton's laws. That's not true. In real science, if you do 24 experiments and they all fail to give you the answer you think you're looking for, there's one thing you can do and only one thing you can do, and that is to throw out your hypothesis and come up with another hypothesis. Well, astronomers have been adamantly opposed to anything electrical. They never liked Birkeland's ideas of charges flowing through space in the first place. But anyway, if you just make some substitutions for what the charge density should be in those equations, bingo, what falls out of those equations is a picture very much like the picture there of M33. The charge density is 1 over r. The velocity in these stars, really, in the real world, and they've been measured like this for 85 years now, they vary as the square root of r. And so the last picture is a comparison of the predicted and actual stellar velocities. So if you take my model of the Birkeland current and assume that it's feeding the rotation in the Birkeland current is responsible for the rotation of the galaxy, that is the comparison between the actual velocity, which is that sort of wiggly, lazy S curve, and the square root of r is the smoother curve there. And that's exactly what my Birkeland current model predicts should happen. So there's no surprises. And these guys have been chasing their tails down a box canyon for 85 years now, looking and crying out that they know that dark matter exists, but they can't find it. That's because there's no reason for it.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. For many decades, standard cosmology has proposed a universe that is disconnected, incoherent, chaotic, strange, and literally dark. In this cosmology, around 96% of the universe is invisible and undetectable, composed of the mysterious entities dark matter and dark energy. In the early 20th century, some noted astronomers proposed the concept of dark matter as a possible solution to the anomalous stellar rotation profiles in galaxies. The mystery was, why do Newtonian dynamics fail to explain the impossibly high velocities of rotation of the outer stars and galaxies? Later scientists using galaxy rotation curves also proposed the apparent need for many times more dark matter than visible mass. For the last 85 years, scientists on Earth have hypothesized many different types of dark matter, and the search continues in earnest today, with astronomical sums invested in the technological quest to prove dark matter's existence. Yet rather than finding any confirmation of dark matter, space scientists have been left empty-handed, with only an ever-growing list of unresolved puzzles. One such new puzzle completely confounds all theoretical predictions for the standard lambda-cold dark matter model. A team of scientists studying the elliptical galaxy Centaurus A has made the astonishing discovery that the galaxy is orbited by a number of dwarf satellites arranged in a, quote, narrow disk. This kind of coherent, non-random arrangement of host galaxies and their satellites is completely unexpected in standard cosmology. As noted in a recent Phys.org report, under the lambda cold dark matter model, smaller systems of stars should be more or less randomly scattered around their anchoring galaxies and should move in all directions. To understand just how problematic this discovery is for standard cosmology, these models and simulations have predicted that only 0.5% of nearby satellite galaxy systems should exhibit this kind of pattern. However, to astronomers' complete bafflement, 14 of the 16 Centaurus A satellites display this pattern of common rotation along the main galaxy's plane. And this is not the first instance when scientists have documented satellite dwarf galaxies co-rotating in a, quote, preferentially oriented alignment around a central galactic mass, producing a, quote, vast polar structure. As noted in the Phys.org report, scientists have measurements for 11 Milky Way satellite galaxies, 8 of which are orbiting in a tight disk perpendicular to the spiral galaxy's plane. There are probably other satellites in the system that can't be seen from Earth because they're blocked by the Milky Way's dusty disk. An earlier study also found that out of the nearby Andromeda galaxy's 27 dwarf satellites, 15 show the same impossible alignment. A lead author of the study said of the new findings, "There should be pure chaos and not order. To find everywhere we look this extreme order where we expect disorder, this is strange." Study co-author Marcel Pawlowski stated, "This means that we are missing something. Either the simulations lack some important ingredient, or the underlying model is wrong. This research may be seen as support for looking into alternative models." Such alternative models offered by the electric universe and plasma cosmology can no longer be ignored by institutional science. In the electric universe, Birkeland current filaments pervade all of space, traveling from the sun to the Earth to power the auroras, flowing through molecular clouds and electromagnetically pinching material to form stars, and even organizing material over the vastest cosmic distances to form galaxies. In this view, space has a substructure of twisted pair current filaments, with stars and galaxies forming along them like pearls on a string. In a forthcoming episode, retired professor of electrical engineering Dr. Donald Scott will explain why cosmic-scale Birkeland currents may indeed eliminate the perceived need for dark matter. In a scientific paper published in 2015, Dr. Scott offered his original modeling of a Birkeland current structure, identified visually as counter-rotating cylinders, as seen in the earthly auroras, and at the poles of the gas giants Saturn and Jupiter, respectively. Scheduled for publication in April of this year in the journal Progress in Physics, Dr. Scott's paper, Birkeland Currents in Dark Matter, explores the Birkeland current as an explanation for the mysterious stellar velocity profiles within galaxies. As seen in this graph, the predicted stellar velocities based on Dr. Scott's model and the actual stellar velocities measured over nearly a century compare remarkably well. In this brief clip of his forthcoming presentation, Dr. Scott explains as follows.
the velocity in these stars, really, in the real world, and they've been measured like this for 85 years now, they vary as the square root of r. The last picture is a comparison of the predicted and actual stellar velocities. So if you take my model of the Birkeland current and assume that it's feeding the rotation in the Birkeland current is responsible for the rotation of the galaxy, that is the comparison between the actual velocity, which is that sort of wiggly, sort of a very lazy S curve, and the square root of r is the smoother curve there. And that's exactly what my Birkeland current model predicts should happen. So there's no surprises. And these guys have been chasing their tails down a box canyon for 85 years now, looking and crying out that they know that dark matter exists, but they can't find it. That's because there's no reason for it.
For Dr. Scott's full interview and for ongoing analysis of these scientific developments, stay tuned to Space News from the Electric Universe.
Meet the
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A new picture of the cosmos is emerging, a vastly different picture than the one astronomers have been painting for over a century, but a picture that was drawn many decades ago by specialists in plasma and the electrical sciences. In this picture, antiquated notions of charge neutrality in space have been erased, replaced with theoretical models which recognize the pervasive conductive medium, or fifth state of matter called plasma, through which electric currents flow throughout the cosmos. For many decades, electric currents were, and in some instances remain, verboten in the space sciences. But with improved instrumentation and ever finer data, cosmic electric currents at all scales are now undeniable. Nevertheless, a strange dilemma is unfolding in astronomy and astrophysics. Scientists attempt to explain electric currents in space through theoretical models in which electricity does not cause anything. But as we will see, electric currents in space are not just a curious byproduct of gravitational and magnetic phenomena. From the Electric Universe perspective, the measurement of electric currents in space is the inevitable recognition of the electrical circuitry that connects celestial bodies across interplanetary, interstellar, and intergalactic space. It's essential to remember that electric currents are only visible when they meet regions of dust and gas, where one sees the unmistakable filamentary structure of electrified plasma, as in the vast star-forming networks in our own Milky Way. Measuring the strength of cosmic electric currents is, of course, no easy matter for scientists on Earth, and is even vastly more challenging than estimating the strength of cosmic magnetic fields. A good recent example can be found in our own solar system and scientists' investigation of the Saturnian moon Enceladus. As we outlined in a recent Space News, prior to the arrival of the Cassini spacecraft at Saturn over a decade ago, planetary scientists had expected Enceladus to be, quote, geologically dead. Instead, they found explosive filamentary jets shooting material at tremendous velocities up to hundreds of kilometers from the moon's surface. Adding to the surprise, the jets were seen at the moon's south pole, the last place they expected such activity. As reported by Space.com in 2005, the finding flipped everything scientists knew about Enceladus on its head, because what should have been a dead moon appeared to be geologically active, and what was supposed to be the moon's coldest region turned out to be its warmest. Since their discovery, scientists have interpreted the features as so-called ice geysers, which they view as a form of cryovolcanism, probably resulting from Saturn's gravitational forces producing tidal heating within the moon. In 2008, Cassini's plasma spectrometer discovered evidence for electrical currents in the plumes of water and dust. In recent years, a number of papers have been written on the presence of negatively charged dust grains in the so-called plumes. And now, based on data from the Cassini-Langmuir probe, a new scientific paper is providing evidence that these dust grains have actually, quote, blocked the signal of the powerful electrical currents in the Enceladus jets. For a number of years, standard theory has proposed that electrically neutral water molecules are ejected from the moon's surface, where UV rays from the sun and interactions with plasma in Saturn's magnetosphere strips electrons from water molecules, forming positively charged water ions. In theory, these ions are then free to be, quote, picked up and merge with co-rotating plasma, supposedly generating an electric current. Cassini scientists had estimated the strength of the jet's electric currents based on disturbances to Cassini's magnetometer instrument. But as noted in a summary of the new scientific paper in the Journal of Geophysical Research, when Cassini flew through the icy plume, its instruments sent back vastly different readings. According to the craft's Langmuir probe, which measures particle density, there were enough ions present to generate a current of 10 million amps. The magnetometer indicated a current more than 20 times weaker. The authors provide experimental evidence that ions like those in the Enceladus plume are, quote, attracted and trapped within the sheaths of negatively charged dust grains. They conclude that, quote, Cassini's Langmuir probe is measuring the entire ion population, both free and trapped ions, while the Cassini magnetometer detects the magnetic perturbations associated with pickup currents from the smaller population of free ions, with this distinction possibly reconciling the ongoing debate in the literature on the ion density in the plume. Simply put, the results are anomalous for the standard, quote, pickup ions model. But they are expected if the surface of Enceladus is being etched by electrical discharge machining, as our chief science advisor Wal Thornhill has always proposed. Electrical discharge machining works by stripping electrons from high points on a surface. In this process on Enceladus, positive ions generated on the surface are heated by electric discharge and electrostatically attracted to follow the electrons into space. This would in fact explain the high loading of positive ions that the Langmuir probe measured. And as we reported in great detail in a recent space news, the notion that the gravitational influences of the gas giants Jupiter and Saturn produces tidal heating in their respective moons, resulting in cryovolcanism, has never been more questionable in light of new discoveries. As we noted, in 2013, scientists reported that the locations of the so-called volcanic plumes on Io are completely incompatible with the moon's internal heat signatures, a finding which, according to lead author Christopher Hamilton, can't be reconciled with any existing solid-body tidal heating models. Likewise, on Enceladus, in 2016, scientists were amazed to discover that when the so-called geysers on the moon are producing the most water and dust, the accompanying gas output was anomalously low. As reported by Space.com, the researchers expected quite a lot more gas expelled at the far part of Enceladus's orbit to help explain the outpouring of dust, but they found the gas output had bumped up by just 20%, far less than expected. The leader of the study said of the findings, "We had thought the amount of water vapor in the overall plume across the whole south polar area was being strongly affected by tidal forces from Saturn. Instead, we find that the small-scale jets are what's changing." Both scientists' new insights into the strength of the electric currents in the Enceladus plumes and the failure of the tidal heating models to explain discovery are stunning victories for the electrical interpretation of the phenomenon. Of course, given scientists' difficulties in accurately measuring the electric currents at Enceladus, this naturally emphasizes the present technical and observational constraints on quantifying the electromagnetic energies at the vastest cosmic scales. However, as we've reported in many recent episodes, the evidence for cosmic scale electric currents is being more and more routinely presented in mainstream scientific literature. One of the most spectacular electromagnetic phenomena in space is the many light-years-long collimated jets produced at active galactic nuclei. Today, standard astrophysics offers no explanation for the phenomena that does not involve a hypothetical black hole producing tremendous magnetism. However, with increasing regularity, mainstream scientific literature has proposed that the jets are composed of powerful electric currents. From radio astronomers estimating the current in an extragalactic jet supposedly the equivalent of 1 trillion bolts of lightning, to more recent scientific papers which describe a, quote, battery mechanism close to the hypothetical black hole producing electric currents. As a recent paper by Gabuzda et al. States, astrophysical jets are fundamentally electromagnetic structures. Nevertheless, in every case, astrophysicists can only envision colossal gravity producing magnetic fields, which are somehow primary in the creation of the spectacular, quote, cosmic lightning. A recent Phys.org report describes new findings that can only confound the standard interpretation of so-called black hole jets. As matter is broken down around a black hole, jets of electrons are launched by the magnetic field from either pole of the black hole at almost the speed of light. Astronomers have long been flummoxed by these jets. But this view is not supported by new research into the magnetic field surrounding a, quote, black hole that is believed to be in our own Milky Way, within a microquasar in the constellation Cygnus. The Phys.org report summarizes the findings. The team observed the magnetic field of a black hole within our own galaxy from multiple wavelengths for the first time. They discovered that magnetic fields are much weaker than previously understood, a puzzling finding that calls into question previous models of black hole components. The research shows a deep need for continued studies on some of the most mysterious entities in space. However, the real deep need may be for astrophysicists to finally consider actual theoretical alternatives to the black hole's existence. As stated many times by physicist Wal Thornhill, what these increasingly problematic discoveries highlight is the problem of over-specialization in the sciences, far removed from the spotlight of popular science. For decades, plasma cosmologists have presented experimental evidence that the spectacular electromagnetic phenomena that space scientists attribute to black holes is in fact a high-density energy storage phenomenon demonstrated in laboratories, called a plasmoid. In several episodes, we have briefly described how a plasmoid is a kind of load in a galactic electrical circuit, concentrating and storing energy. When a plasmoid reaches a threshold density, it will discharge, usually along a galaxy's spin axis, producing the stupendous galactic jets whose electric currents are now increasingly recognized in mainstream scientific literature. All astrophysicists who seek an answer to the mystery of cosmic jets should be acquainted with the experimental research into the plasmoid's applicability to cosmic phenomena. We encourage viewers to consider the landmark research of the scientific pioneer, the late physicist and MIT scientist Winston H. Bostick, whose experimental research on the plasmoid led to the development of the dense plasma focus device. Bostick simulated many astrophysical phenomena through plasma physics experiments, including galaxy formation and spectacular cosmic jets. The jets' collimation over tremendous cosmic distances, the knotted structures seen in many jets, their nearly light-speed velocity, their emissions of synchrotron radiation, and now the inferred measurements of electric currents in the jets are all the predictable features of a discharging galactic plasmoid. Since the plasmoid's jets are part of a vastly larger electrical circuit, this can also resolve an enduring, intractable problem for astrophysicists, which is the mysterious source of the energy to the most distant parts of the cosmic jets, sometimes over many hundreds of thousands of light years. Occam's razor states, the simplest explanation is the most likely. Standard astrophysics tells us that electric currents in space are the product of extremely complex and strange gravitational and magnetic processes. The electric universe states that electric currents flow through the conductive medium of plasma, which composes more than 99% of the visible universe. Celestial bodies moving in electrified environments are electromagnetically connected and will discharge electrically when experiencing dramatic voltage spikes, as we see on our own planet in the form of spectacular blue jets, elves, and red sprites above the clouds reaching towards space. Electric currents in space mean only one thing: we live in an electric universe.
I'm London Breed. I know what it's like.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In recent years, a profound development has been unfolding in astrophysics. The inevitable acknowledgement of tremendous electric currents at the largest cosmic scales. One of the most stupendous electromagnetic cosmic phenomena is the collimated, light-years-long jets produced at active galactic nuclei. Recently, the obvious electrical nature of these jets has been explored in scientific papers, published in peer-reviewed journals. One such paper, entitled "The Jets of Active Galactic Nuclei as Giant Coaxial Cables," summarizes, "Our results have now yielded firm evidence that many, possibly all, active galactic nuclei jets have inward currents along their axes, and outward currents in more extended regions surrounding the jets. It also indicates that astrophysical jets are fundamentally electromagnetic structures." Another paper, entitled "Electric Currents Along Astrophysical Jets," also argues for cosmic scale electric currents, though also doing so from the framework of gravitational theory. The author states, "Several researchers have reported direct evidence for large-scale electric currents along astrophysical jets. Quite unexpectedly, their directions are not random, as would have been the case if the magnetic field were generated by a magnetohydrodynamic dynamo. Instead, in all kiloparsec scale detections, the inferred electric currents are found to flow away from the galactic nucleus. This unexpected break of symmetry suggests that a battery mechanism is operating around the central black hole." And here we see emphasized the fundamental differences between standard astrophysical theory and plasma cosmology and the electric universe. Astrophysicists can only imagine colossal gravity, a black hole, producing tremendous magnetism, which then produces the stupendous electric currents. In this episode, retired professor of electrical engineering Donald Scott offers the electric universe interpretation, first addressing a basic problem in cosmology. What is the real source of magnetism in space?
We have to realize that magnetic fields are caused by one thing and one thing only, and that's the movement of charge. In other words, electric currents. Electric currents create magnetic fields, and when magnetic fields collide with conductors, then currents will be induced, that is to say initiated, created in those conductors. You can't have one without the other. But anyway, they've been very reluctant to mention electric currents until very, very recently, where they do indeed mention electric currents. So one was electric currents along astrophysical jets by Ioannis Kontopoulos. When I saw this, we were all like, wow, electric currents in jets, that sounds just like Birkeland currents. Until you begin to read the article, and I do admit they do mention electric currents, so that's 2 points to windward, and that's good. But I think it's the first sentence in the article. Astrophysical black holes and their surrounding accretion disks are believed to be threaded by grand design helical magnetic fields. There is strong theoretical evidence. Now, I don't know what strong theoretical evidence means. There's either strong observational evidence or a well-believed theory, but there's not just no such thing as strong theoretical evidence that the main driver of their winds and jets is the Lorentz force generated by these fields and their associated electric currents. That's good. The Lorentz forces certainly are at play in Birkeland currents. Then they go on, they said several researchers have reported direct evidence for large-scale electric currents along astrophysical jets. Good. Quite unexpectedly, their directions are not random, as would have been the case if the magnetic field were generated by a magnetohydrodynamic dynamo. Uh-oh. There we go again, dynamos. If you look up the definition of dynamo in Wikipedia, and I did it just to be sure I was right, a dynamo is an electrical generator that produces direct current. In other words, it's a DC generator. It's the way Edison made DC current in Chicago, I think it was. But it has nothing to do really with what's going on in space. I don't think we really have any use for dynamos, but they use this word almost like a magic shibboleth that it's a dynamo caused it. Anyway, magnetic fields are an important constituent of cosmic plasmas at all astrophysical scales. They are thought to be produced by seed fields generated by random currents that are amplified by dynamo action in planetary and stellar interiors, accretion disks, and generally rotating astrophysical plasmas. I mean, other than the fact that they mention astrophysical plasma, everything there is wrong or non-existent. There's no such thing as an accretion disk. They like to think about it. It's well known that Tony Peratt said that in Los Alamos laboratory, they would try to simulate an accretion disk and totally failed miserably. They couldn't do it. And if they mixed plasma in with their simulation and allowed for Maxwell's equations to be used as well, then yes, you could get the thing to accrete. But without plasma, without electricity, there's no such thing as a magnetic accretion disk. But anyway, there's another paper which I think is less obviously wrong in many of its points, but still has some things to worry about. That one is the jets of AGNs, active galactic nuclei, as giant coaxial cables. This paper was written by Denise Gabuzda and her associate authors Nagel and Roach from the Department of Physics at University College, Cork, Ireland. And the first sentence in that paper is, active galactic nuclei, AGNs, release vast amounts of energy, whose ultimate source is a supermassive black hole in the galactic nucleus, in so-called radio-loud AGNs. Remember that radio-loud. That's important. Radio-loud AGNs, two relativistic jets of plasma emanate from the nucleus, presumably along the rotational axis of the black hole. In other words, they can't let go of black holes and gravity and all this other nonsense when the evidence is right in front of their face. She says radio-loud AGNs. What makes loud radio noise? Answer, double layers. That's been well known for decades, since Hannes Alfvén won the Nobel Prize in 1970. Let me just conclude by saying, in the end of that paper by Gabuzda, her figure 2 is almost an identical figure to one that I published in my paper in Progress in Physics in 2015. It's a cross-section of the Birkeland current. It shows counter-rotating currents and magnetic fields, and that's indeed true. So if she gets it that right, why can't she let go of the supermassive black holes? There's no excuse for anyone with any claim to being an investigator of cosmic phenomena not to know about the seminal plasma work of people like C.E.R. Bruce, Ralph Jurgens, Earl Milton, Wal Thornhill, Tony Peratt, Hannes Alfvén, Birkeland, and many others. These people have staked out their rightful claims years ago, and it's shameful that their work is being ignored as if they never had lived and worked for years to promote these concepts.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Hi everyone, I'm Dr. Nancy Lynn. Most people know me as a holistic nutritionist, but I'm also a certified yoga instructor, and fitness is a really big part of my life. As an athlete and mom to 3 high-energy kids, my joint health is really important to me because it allows me to practice at a high level every day.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In a recent Space News episode, Thunderbolts colleague, physicist Eugene Bagashov, offered his analysis of what is thought to be the first ever observed interstellar asteroid. As Eugene explained, the object's origin and behavior appear to offer no easy answers. either for standard astronomy or the electric universe. Today, Eugene continues his discussion with some new thoughts on the mysteries the asteroid has raised.
Let us continue our consideration of the so far unique object Oumuamua, supposed to be the first known interstellar asteroid. I'll remind that the previous episode was devoted to the somewhat problematic fact that although this object possesses a hyperbolic orbit, it does not demonstrate any cometary activity, which one might expect from the standpoint of the electric comet hypothesis. Later on in this video, I would propose another possible explanation for this from the electrical perspective, but first let us discuss the recent research paper devoted to Oumuamua. In this paper, the authors look at the actual spectroscopical data on this object, trying to make guesses about its surface composition following from its spectrum. In short, their conclusion is that it seems that the surface should be covered by some sort of carbon-rich substance formed under prolonged exposure to the cosmic ray radiation in the interstellar medium. They also suppose that this substance might be thick enough to thermally insulate the interior of the object. So they conclude that in this case Oumuamua might actually have quite a high ice content, but the ices did not sublimate even at the perihelion because of this external insulation. Now, I don't have enough expertise in this area to judge whether they are correct in the assumption that the characteristic dark and slightly red color of Oumuamua is caused by organic compounds, but I wish to mention another paper from 2015 where the other group of researchers have tried to recreate the space weathering effects on silicate minerals in the laboratory conditions. Their results show that the darkening and reddening that is frequently observed on small bodies in the solar system might be caused by the particles of nanophase iron that form under the bombardment of energetic hydrogen ions. Essentially, what seems to happen is the disruption of the crystal lattice of the surface minerals, followed by their oxygen atoms forming hydroxyl groups and water molecules with the incoming hydrogen, which is the very same mechanism that is supposed to be the primary source of water in comets in the electric comet hypothesis. Thus, the iron from the surface minerals, having lost the binding to the oxygen, is being reduced to its metallic state, forming the mentioned nanoparticle grains. It is not impossible that this is the reason for the observed spectrum of Oumuamua and many other bodies, rather than the carpet of organic compounds. Anyway, the hypothesis of thermal insulation of Oumuamua's interior by the thick surface layer that the authors of the first paper propose seems to lend a helping hand to the dirty snowball model in explaining the lack of the activity of the object. Essentially, in this framework, Oumuamua might be just a regular comet, which means supposedly a piece of ice mixed with dust, but it is the prolonged exposure to the cosmic rays that have formed the insulating surface layer, which inhibits the sublimation, making the cometary activity impossible. Curiously enough, this seems to work for the electric comet hypothesis just as well. If the silicates on the surface of the rocky object would be buried under a layer of some organic molecules, perhaps one would also expect the lack of cometary activity, since there is no direct access of the incoming hydrogen ions to the oxygen in the silicates. I would suppose that the difference between these two scenarios is that in the electric comet hypothesis, the required thickness of the organic layer would be less, since we just have to prevent the surface minerals from the direct contact with the solar wind. But in the snowball model, one would expect that a thicker layer would be required, as it must have enough durability to withstand the strong heating at the perihelion, which is impossible to achieve with only a thin layer of insulation. As a side note, this also means that the supposed age of the object in the electric comet perspective might be somewhat less, in the sense that one does not need billions of years of cosmic ray exposure to form only a thin veneer of organic compounds. It might happen much quicker than the formation of a thick layer required by the snowball model. To give you some numbers, the authors suppose that the insulating layer thickness might be somewhere in the range of 0.1 to 2 meters. Anyway, there is a noticeable problem with this hypothesis in the first place that the authors themselves acknowledge. It is the fact that the very same insulating layer should be formed also on the surface of the objects from a hypothetical Oort cloud around the Sun. These objects also should not demonstrate cometary activity if this is the case, supposedly being there for billions of years and accumulating the same carpet of organics. But this is absolutely incompatible with the observations, as the Oort cloud is supposed to be the reservoir of active comets, rather than inert objects insulated by the layers of organic compounds. So perhaps it is reasonable to take this whole research with a good pinch of salt. Now, moving to a slightly different topic. One very important thing that I've missed in the previous analysis was indicated by the people in the comments section, namely GM Trainer and Leo Caldas. In particular, it is the fact that the perihelion of Oumuamua strikingly coincided with an incredible uptick in solar activity. I'll remind you that the date of the perihelion was September 9th, 2017, and exactly the day before, on September 8th, the sunspot area peaked at 1760 millionths of a solar hemisphere. Last time such high area of sunspots was observed on December 19th, 2014, at the very maximum of the current solar cycle number 24. But in September 2017, we were already halfway into the solar minimum, yet the spot's presence was just as pronounced. And not only that, but during the closest approach of Oumuamua, we've also had two strongest solar flares of the whole cycle, X 9.2 on September 6th and X 8.2 on September 10th. The first one was actually the strongest solar flare after the X17 flare on September 7th, 2005, almost exactly 12 years before. So somehow the perihelion of the only known interstellar object coincided with a significant maximum of sunspots and also the strongest flares in 12 years. In my opinion, this does not seem to be a simple coincidence. It is also worth noting that at the very same time the strongest earthquake of this year happened, magnitude 8.2 on September 8th off the coast of Mexico. And it was also the time when two strongest hurricanes of 2017 have formed, Irma and Maria a week later. In my opinion, both the seismic and hurricane activity at that time was provoked by the increase in solar activity, which in its turn was triggered by the perihelion of Oumuamua. So I became curious about the frequency of such occasions. Maybe other significant solar optics also coincided with perihelia of some hyperbolic or parabolic orbits. I used JPL small body database to search for dates of perihelion passages of the known objects with parabolic and hyperbolic orbits in the recent years, namely since the beginning of the year 2011 and until the present moment. The other constraint I've used was the perihelion distance, that is, the distance to the Sun during the closest approach. For this I arbitrarily chose the value of 2.2 astronomical units, which roughly corresponds to the inner border of the asteroid belt. So in the end I was looking for objects that come from somewhere very far away, dive inside the area encircled by the belt only once and then go away never to return again, just like Oumuamua did. I've found 32 such objects with perihelia in the last 7 years. Then I went looking for the significant solar flares, where by significant I mean stronger than M6.0, and marked the days when these events took place in order to find correlation. I've identified 73 days when such flares happened in the last 7 years. I'm not an expert in statistics, so I might be wrong in my analysis, but in order to quickly analyze the possibility of correlation, I've calculated how much of the total time is covered by perihelia of these objects. I've set a time span of 15 days centered on the date of perihelion for every such object, such that if the flare happens in this interval, it is considered as a hit, and considering a miss otherwise. 32 times 15 gives us a maximum of 480 days spanned by these perihelion intervals, or about 19% out of total 7 years. So considering a completely random or at least uncorrelated distribution of both the flares and perihelia, we should expect about 19% of the flares to happen at these perihelia intervals. But in the actual data, I found that 29 out of 73, or about 40% of the days with significant flares, took place during these intervals. So it seems that the probability of a strong solar flare happening during the perihelion of an object on a hyperbolic or parabolic orbit is about twice as high than the one expected without any correlation between these events. We might also look at it the other way. Not all the 32 objects have actually had the significant flares during their perihelia, but only 17, or about 53% of the total number. So maybe there is some pattern in their orbital parameters or something else that might distinguish between the ones that have supposedly triggered the flares and the ones that haven't. So far, I've failed to find any such pattern, yet it does not mean that it is not there. I have highlighted the objects during the perihelia of which there were significant flares with yellow, hoping that maybe someone would be more successful than I was in this endeavor. So here we see the list of the objects and some of their orbital parameters, namely the name, q, which is the minimal distance to the Sun in astronomical units, orbital eccentricity e, inclination I, longitude of the ascending node and argument of the perihelion in degrees, and lastly the date of the perihelion in Julian days. For explanation of these parameters, I recommend watching my talk from the EU 2016 conference, which is available at the Thunderbolts Project YouTube channel. Now getting back to the original discussion about the anomalous lack of activity of Oumuamua during its perihelion, I wish to put forth another quite far-fetched hypothesis. I hope the viewer is not too tired of these yet. So, looking at the situation from the very simplified electrical perspective, one might suppose that what we observed was some sort of focusing of the electrical energy on one object rather than the other. I mean, we might suppose that there is a roughly equal amount of energy for each such perihelion passage, but this energy can be redistributed between the Sun and the object that is getting close to it. Just like the amount and location of electrical power release in a circuit might be adjusted by changing the resistances of its various components. So in this framework, the case of Oumuamua might represent one of the extremes, when almost all the power of the circuit is released at the Sun, and the other object remains inert, which is why we see strongest flares on our star and at the same time don't see any cometary discharge features at Oumuamua. Perhaps it might also solve the cases of these other objects that I've listed earlier. Perhaps those that didn't trigger any significant solar activity were simply too active themselves at the time. This represents an interesting avenue for further research. As for the possible factors determining the redistribution of activity, my best guess so far would be to look at the position of coronal holes and the heliospheric current sheet around the time of perihelion. High-speed solar wind streams from coronal holes with their open magnetic field lines essentially act as highways for charged particles, allowing them to quickly move from the external object to the photosphere of the Sun and vice versa. And the importance of the heliospheric current sheet in the electric perspective is kind of obvious already from its name. So, wrapping up, I wish to once again express my gratitude to all the people who participate in the discussion of this subject in a productive manner, noting such correlations, coincidences, and other patterns which might indicate that there is some sort of connection present between various phenomena in the solar system. I would like to encourage all of you to continue such search and to share your thoughts and the results of your research with others. Luckily, the electric universe paradigm represents a great framework for assembly of such crowdsourced research activities, and I hope it would bring some success in our search for the laws that govern the universe.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
On in this video, I would propose another possible explanation for this from the electrical perspective.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The Saturnian moon Enceladus may be one of the most enigmatic bodies in the solar system. For nearly a decade, since the first close flyby of the Cassini space probe, NASA scientists have faced a series of puzzles that continue to challenge conventional theory. The electrical nature of these puzzling phenomena has grown increasingly evident, leading to the 2012 NASA report, Enceladus plume is a new kind of plasma laboratory. In part 1 of this 2-part presentation, we explore the question, what makes Enceladus such a unique and fascinating case study in planetary science?
Enceladus is a moon of Saturn, orbits just outside the rings. It has one of the most perfect orbits of any moon in the solar system. It's almost a perfect circle. One of its faces always points towards Saturn as it moves around in its orbit. It's almost perfectly aligned in the equatorial plane of Saturn. And what all that means is that the gravity forces acting on it are almost zero. It's almost as if it were sitting still, because all the variations caused by an eccentric orbit or an inclined orbit or a rotation other than synchronous have been zeroed out. So Enceladus makes an almost perfect laboratory in space. Saturn only receives 1% of the sunlight that the Earth gets. Enceladus, in turn, is the most reflective object in the solar system. So of that 1% of the light that Earth gets, less than 1% of that even can heat that little moon. So it isn't being heated by the sun. So that can't be much of a factor for the things we see on this little moon.
Since 2005, NASA scientists have known that Enceladus emits unexpected jets of icy material. Adding further surprise, the jets were found near the South Pole, which NASA scientists had expected to be the moon's coldest region, but which instead turned out to be its warmest. Adding further astonishment, in 2009, Cassini scientists discovered the presence of electrically charged particles in the Enceladus plumes. What can these jets tell us about the obvious electrical environment of Enceladus?
One of the features of Enceladus that is so intriguing are these jets we see coming off of it. They were first discovered back in 2005 when Cassini arrived at Saturn and began looking at the different moons. They didn't announce it until November 2005 because they weren't really sure what they were seeing. But by now it's become perfectly clear that jets of finely divided water particles are coming off of this moon almost continuously. And the main area they come from is the southern region, where there are these 4 parallel bands called tiger stripes, over 100 kilometers long and separated from each other by several tens of kilometers and slightly discolored. And they call them geysers or cryovolcanoes because they cannot imagine any other mechanism that would produce such a feature. But because Enceladus is so perfect in its orbit and there's no heat sources coming into it and there's not enough energy from cosmic rays to power it, the only source of energy for these geysers, as they call them, would have to come from within Enceladus itself. But this little moon is only about 300 miles across. It's a small little ball of ice out in the middle of nowhere. Its surface temperature is lower than the boiling point of nitrogen. It's about 72 degrees above absolute zero. And so the water ice that composes at least its outer layers would be as hard as steel and colder than anything we would care to touch. So anything that would heat up inside of it, the ice would want to conduct that heat away before it could ever get more than a few degrees above the boiling point of liquid nitrogen. So the heat conduction problem is one of many problems with the geyser theory. But another problem is that if it were water being heated up and launched off of Enceladus, that's actually a description of how a rocket engine works. So if Enceladus has geysers, then Enceladus has its own onboard rocket engines. And those rocket engines, no matter how tiny their thrust, would be moving it in its orbit. It would be distorting it in some fashion, either in eccentricity, which is nearly circular, or in inclination, or in major axis, either making it come closer to Saturn or move further away. And we don't see any of that happening. And if it were a heat source now, it would have been a bigger heat source in the past if it was radioactive or chemical. And so these rocket engines would have been even more powerful. And so the idea that Enceladus could end up in this perfectly circular orbit is statistically just about impossible. These engines firing off more or less in random directions would be doing something to disturb that orbit. So they're really at a loss to explain how an internal heat source could be causing these jets to be escaping from Enceladus and not disturbing its orbit. It's a series of scientific problems, a chain that's with every link is very, very speculative and weak. And that's why we in the electric universe don't think these are geysers at all.
In 2011, NASA scientists found that the heat output in Enceladus's south polar region is more than an order of magnitude higher than their models had predicted.
NASA scientists recently determined by calculation that the power levels involved are something like around 15 gigawatts. And that would be like about, at least a dozen nuclear power plants worth of power being generated in these jets coming off of Enceladus. Well, that's quite a bit of power for a moon that has no evident external heat source, and it appears to be composed of ice at a temperature of liquid nitrogen. So where could such power be coming from? Well, if such power is coming from within, and if such power is generated radioactively, which is what their main theory is, that means that inside Enceladus are more than 12 nuclear power plants worth of radioactive decay. We haven't even found such a thing on Earth. So either the power of these jets is coming from within Enceladus, or it is being supplied from elsewhere. This little moon is orbiting Saturn in its magnetic field, which is in turn being fed by power either coming toward the sun or electric power coming from the sun. More likely, Saturn is acting as a cathode in the overall heliocentric circuit that powers the sun. It's intercepting part of that, and in turn, Enceladus is intercepting some tiny, tiny fraction of that. In fact, we have a number, 15 gigawatts, at least for the Tiger Stripe area. The power levels involved in the solar circuit are far more than needed to explain the features on this little moon.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
In a world forced to choose between features and affordability,
News from the electric universe, brought to you by the Thunderbolts Project at thunderbolts.info. A recent discovery by astronomers using the Pan-STARRS telescope is challenging many popular ideas about supernovae. The astronomers report having observed what they call a young supernova in an elliptical galaxy where stars are no longer forming. Lead author Nathan Sanders says of the discovery, "This supernova is one of a kind, and it's definitely in the wrong neighborhood." However, countless surprising discoveries in recent years have challenged long-held theories about the very nature of stars. What are we to make of these discoveries in light of this latest astronomical puzzle?
This supernova is in an old elliptical galaxy in a region where there are no stars being born. So this raises some questions at the end of the article. It says, is this a runaway star from another star formation site? Is it a very local bit of star formation? Is it a different way for such a supernova to occur? None of these seems very likely, so we have a real puzzle. Well, the problem stems from the theory of stars themselves. In fact, the models of stars are so complex that they are non-predictive. One wag suggested you could just as easily come up with a koala bear as a star from the complexity of the theory. The other thing is that a supernova explosion is not really understood. It's a very clever model, but it's totally beyond belief. You have a star which suddenly switches off a theoretical engine at the center, its nuclear furnace, and it suddenly implodes. So this requires the switch off to be sudden, and not only that, the implosion then has to rebound to form the explosion. Of course, this kind of model you would expect would form a spherical shell of material racing away from the star. But what do we see when we look at supernovae? Generally, they have an axis along which matter is ejected. So it's not spherical, the explosion. So this is another puzzle. In fact, it was June last year, it was reported that supercomputer models of supernovae failed to explode. All they did was to implode and collapse. So it's not surprising that astronomers are puzzled. This particular supernova shows a high degree of helium, which also is unexpected. So it was even suggested that perhaps this particular supernova was another type which is due to white dwarfs exceeding a certain mass and then exploding. And so they said maybe it was a collision of two white dwarfs, one of which was helium-rich. So you can see these special conditions that are being introduced in order to try and explain this supernova. Now, it's just a couple of years ago that I had published in the IEEE Transactions on Plasma Science my explanation of supernova 1987A, which shows structure. It showed 3 rings which were centered on an axis through the star, and these rings were made of bright beads. The one nearest the star, encircling where the star was, were very bright, and those further away were dimmer. But this kind of structure is just not explained by any theory of an exploding star.
Much of the strange and encumbered reasoning behind the standard supernova theory may be resolved if a supernova is reinterpreted as an electrical discharge.
In the electric universe model of stars, the complex chemistry to produce the heavy elements inside the star is unnecessary in a supernova. The idea is, of course, that there are populations of stars, and the first population of stars exploded and threw all of the heavier elements out into space where they were collected to make the second population of stars. Now, this is a very messy and inefficient way of producing the stars that we see in our own galaxy, for instance. Also, wherever you look, astronomers are finding anomalies in chemical compositions of stars, stars that shouldn't be there. They're the wrong age, the wrong population. Recently, looking at globular clusters, they've been puzzled by the chemical composition of those stars because it was thought they must have all been produced at the same time in the same event, and yet they're finding compositions which don't fit that picture. In the electric universe, all stars produce heavy elements at their surface, in their photospheres, where strong electrical discharge activity is taking place. And of course, on Earth in the laboratory, this is exactly the way we produce isotopes and heavier elements in the laboratory, is by electrical power applied to accelerators. So there's nothing mysterious there. The standard model, on the other hand, requires purely theoretical and untestable things to be going on unseen inside stars. When it comes to star exploding, the electrical model is simplicity itself, and it doesn't require the star to be of any particular age, because in the electrical model, of course, electrical power is supplied to all stars and is the source of their light and heat and the radiation from them. Now, Hans Alfvén pointed out that the circuits in space also include what are called double layers, where charge is separated across a very small region of space. Those double layers can act like a switch, and if that switch is thrown, then the circuit is broken, and all of the energy stored in the magnetic fields of that circuit, which can extend far beyond the star into the galaxy itself, is concentrated on that double layer, that switch. And that switch can actually be at the surface of a star. So a supernova explosion is purely an electrical explosion. It's the kind of thing that has been photographed, and you can see on YouTube, when high voltage transmission power lines, the circuit is opened at an inappropriate time, and a huge arc stretches between the two electrodes as they separate. So you could say that what you're looking at in a supernova explosion is the opening of a stellar switch, when that star suddenly brightens to the point where it can outshine all of the rest of the stars in that galaxy.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
Have you ever slept on CO2?
Wie soll das denn gehen, bitte?
Also ich kann mir fantasievoll vorstellen, wie ich auf einer Wolke schlafe.
Auf CO2 schlafen?
Why not? With the help of an innovative technology, we are turning CO2 from a waste product into a raw material for foam that is made into mattresses. Discover how we did it on this website.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. The picture of the formation, evolution, and death of stars is changing with each new discovery. The electric universe theory has offered predictions for stellar phenomena that have proved far more successful than those of gravity-centric cosmology. Stars do not form in a process of gravitational collapse, but rather they form from the electromagnetic pinch effect along vast filaments of remarkably constant width. Stars are not powered by internal thermonuclear reactions. Rather, the sun is a positively charged electrode at the focus of incoming electrical currents. Stars do not collapse and explode when they, quote, burn up their nuclear fuel. Rather, electric stars have internal charge separation and can relieve electrical stress by fissioning or blowing off charged matter. In fact, the standard theory of a supernova, which has never been shown to work experimentally, has grown more severely challenged with each new discovery. In November of 2017, a paper published in the journal Nature reported the observation of a star that exploded, somehow survived, then exploded again more than half a century later. A Phys.org report describes the discovery as follows. The finding, published by Nature, completely confounds existing knowledge of a star's end of life. Somehow, this star exploded more than half a century ago, survived, and exploded again in 2014. A co-author of the paper stated, "This supernova breaks everything we thought we knew about how they work." In part one of this three-part presentation, the chief science advisor to the Thunderbolts Project, physicist Wal Thornhill, will begin our discussion on the nature of stars with an examination of so-called neutron stars, hypothetical entities which were invented in the 1960s after the unexpected discovery of pulsing electromagnetic emissions in space. But as Thornhill explains, like the standard theory of supernovas, the hypothetical neutron star is a questionable proposition at best.
It was argued in a recent space news that bizarre whirling neutron star lighthouses are not needed to produce rapidly flashing pulsar signals. Conventionally, neutron stars are believed to be the remnants of a supernova explosion. But supernova explosions are said to be not fully understood, which means keep sending money. So exploding stars are a good place to begin exploding theories. Neutrons are only seen to exist outside an atomic nucleus for a few minutes before they separate into an electron and a proton. So we can't just assume they can be packed closely together to form the bulk of a stable star. Insisting that neutrons exist in atomic nuclei forces an unconvincing nuclear model upon us, with positive charges held together by an ad hoc, strong nuclear force. There appears to be very strong statistical evidence that an atomic nucleus is made up of protons in a rapidly revolving geometric structure where electrons are in sufficient numbers to occupy, on average, the midpoint between pairs of protons. The attractive force to the closer electron overcomes the powerful repulsive electric force between pairs of protons. This greatly simplifies many subjects in atomic and nuclear physics. So we can forget neutron stars. They don't exist. It's far simpler and more likely to suggest that a normal stellar body subjected to abnormally high electrical stress is the source of the steady flashing signals from pulsars. The disturbing fact is that plasma physicists have shown this both theoretically and experimentally. The electrical model of stars is real evidence-based science. Further support for the electrical model recently came from the discovery of gamma-ray flares coming from the Crab Nebula, which encloses a pulsating supernova remnant only 6,500 light-years away in the constellation Taurus. In Physical Review letters of November the 24th, there appeared a letter titled "Inductive Spikes in the Crab Nebula, A Theory of Gamma-Ray Flares" by John Kirk and Gwenaël Giacinti. They report, the detection of powerful gamma-ray flares from the Crab Nebula by the Agile satellite and the Large Area Telescope on the Fermi satellite has provided theorists with three major puzzles. How are particles able to emit synchrotron radiation well above the 100 mega-electron volts astrophysical upper limit? What is the geometry and location of the source, given that it varies on a time scale of hours, whereas the nebula has a light crossing time of months? By which mechanism can such a small source achieve a power of only one order of magnitude less than that of the entire nebula? On November 27th, it was reported in more popular fashion in The New Scientist under the banner, "Mysterious Gamma Rays in Crab Nebula Traced to Pulsar Winds." It says, and I quote, "Waves of charged particles slamming into gas and dust may be responsible for unexpected super bright flashes in the Crab Nebula. In 2011, two telescopes observed unusual short-lived gamma-ray bursts in the Crab. These exceeded 100 mega-electron volts, hundreds of times brighter than the nebula's normal emissions. The source of the flashes was a mystery. Some suspected it had to do with the pulsar's magnetic field splitting or becoming knotted as they move away from the star and into surrounding material. Now, new research pins the gamma-ray emissions on charged particles like electrons and positrons that flow from the neutron star at near light speed, like a constant breeze. Here we see the blind spot of astrophysicists toward electrical effects in space. They can't see beyond explosive winds slamming into slow-moving matter and mysterious magnetic fields which are tied in knots and magically cut and reconnected to somehow produce what are clearly electrical effects. What we are not told is that physicists in the 21st century have no physical understanding of the magnetic force, just equations. Magnetic field lines are a graphic representation and not a real thing. Magnetic field lines must always terminate at a magnetic pole. They cannot be disconnected and reconnected in empty space. The only electrical reference in the report is to the gamma-ray energy measured in excess of 100 MeV. This voltage is easily exceeded across a cosmic plasma double layer, which form in a Birkeland current in a stellar or galactic circuit. But astrophysicists don't do circuits in space because they are taught electricity doesn't do anything in space. Back in 1986, the pioneering Nobel Prize-winning plasma cosmologist Hans Alfvén said, "Double layers in space should be classified as a new type of celestial object. It's tentatively suggested that X-ray and gamma-ray bursts may be due to exploding double layers. In solar flares, double layers with voltages of 10 billion volts or even more may occur. And in galactic phenomena, we may have voltages that are several orders of magnitude larger." Alfvén was right. It is the simple mechanism behind all of the mysterious gamma-ray bursts in deep space. He explains further, if the current density is too high, an exploding double layer may be formed. This means that in the plasma a region of high vacuum is produced. The plasma refuses to carry any current at all. At the sudden interruption of the circuit, inductance produces enormous overvoltages which may be destructive. The result is a high-energy flash of X-rays, gamma rays, and cosmic rays. Here we see the dramatic release when a circuit breaker opens of the electromagnetic energy stored in a long-distance 500,000 volt transmission line. A voltage pulse across the opening circuit breaker rises to millions of volts, causing a powerful arc several meters long. That same voltage pulse in the stellar circuit accelerates charged particles to energies capable of generating the observed gamma-ray flashes. It shows how a small source can achieve a power only one order of magnitude less than that of the entire nebula. The astrophysicist's conceptual blind spot is evident when we look at the explanation for the gamma-ray flashes offered by scientists, where they actually describe the exploding double-layer effect without recognizing the electrical cause. New research pins the gamma-ray emissions on charged particles like electrons and positrons that flow from the neutron star at near light speed, like a constant breeze. We propose that at some moments you have pockets inside this wind where the density of electrons and positrons drops, says Gwenaël Giacinti at the Max Planck Institute for Nuclear Physics in Heidelberg, Germany. Lines of electromagnetic force usually maintain a constant current. When they encounter these lower density pockets, that current is disrupted. Some of the energy in the particles gets converted into kinetic energy, causing the electrons and positrons to accelerate and smash into the nebula's gas and dust. The effect is similar to the behavior of a circuit containing an inductor. Should the current in the circuit suddenly drop, the inductor, which acts to smooth out the electric current, will try to rapidly counteract the loss with a huge pulse, often resulting in a spark. The effect is not similar, it is precisely that of an exploding double layer. As for the wind with its pockets and lines of electromagnetic force maintaining a constant current, the concepts are adrift from any real physical model involving electricity supplied by a galactic circuit. Instead, the Crab Nebula is treated as an isolated, closed system, so the descriptive words are either misleading or meaningless. Of course, there's no reference in the paper to Hans Alfvén and his 31-year-old explanation for high-energy gamma-ray bursts based on the tried and tested physics of electrified plasma.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On this series, we have explored the significance of the filamentary structures seen at all scales throughout the cosmos. From the streaming filaments seen in the ion tails of comets, to the giant snake-like filaments reaching from the surface of the Sun to the dark cores of sunspots, to the stupendous filamentary networks intimately linked to star formation in the Milky Way galaxy, to the web-like filaments along which galaxies form, like pearls on a string. Filaments in space are the expected features of a universe where electric currents connect celestial bodies across cosmic distances. Electrical circuitry pervades interplanetary, interstellar, and even intergalactic space, which can be seen when electric currents meet regions of dusty plasma and pinch the material into visible filaments. It's therefore no surprise that the discovery of huge filaments in space continues to send mainstream scientists searching for answers. Recently, astrophysicists using the Very Large Array Telescope have made what for them is a completely unexpected discovery near the center of the Milky Way galaxy. What they have found is a nearly 2.5 light-year-long filament that is, quote, probing the hypothetical black hole at Sagittarius A. The December 20, 2017 Phys.org report describes the discovery as follows. The center of our galaxy has been intensely studied for many years, but it still harbors surprises for scientists. A snake-like structure lurking near our galaxy's supermassive black hole is the latest discovery to tantalize astronomers. The leader of a study on the discovery stated, "With our improved image, we can now follow this filament much closer to the galaxy's central black hole, and it is now close enough to indicate to us that it must originate there. However, we still have more work to do to find out what the true nature of this filament is." The investigators are only considering 3 possibilities to explain the mysterious filament. One is that the hypothetical black hole, quote, kicked away high-speed particles, somehow forming the light-years-long filament. This would involve the black hole's rotation pairing with spiraling gas to produce an incredibly powerful magnetic field. Another possibility they've entertained is that the filament is a mathematical conjecture called a cosmic string, which theoretical physicists have proposed may have formed in the early universe, but which have never been discovered. Ironically, as described in the Phys.org report, it's believed that hypothetical cosmic strings are, quote, long, extremely thin objects that carry mass and electric currents. The final notion the scientists have considered is that the alignment of the filament with the galactic center is coincidence. However, as the Phys.org report states, such a coincidence is quite unlikely to happen by chance. Unfortunately, the investigators are not considering other, more promising possibilities, namely that the hypothetical black hole at the galactic center simply does not exist. As we noted in the recent episode, Black Holes Behaving Badly, in astrophysics today, the black hole has become an unfalsifiable concept. In our own Milky Way, it appears that no discovery, including the recent observation of star formation occurring much too close to the hypothetical black hole, where tidal forces must rip the gas and dust apart before it can form stars, will force any doubt of the black hole's existence. As we've outlined many times, the position of plasma cosmology and the electric universe is that it is not a black hole at the center of galaxies, but an ultra-high density energy storage phenomenon demonstrated for decades in laboratories called a plasmoid, which is a kind of load in the galactic electrical circuit. The plasmoid concentrates and stores energy and is connected to a larger network of electric currents. When the plasmoid reaches a threshold density, it discharges, usually along a galaxy's spin axis. This is in fact the source of stupendous galactic jets. The discovery of a vast filament such as that recently observed is expected and is in fact required if it is a plasmoid at the galactic core. As we've noted several times recently, the role of magnetic fields in sustaining cosmic filaments is now being discussed with increasing frequency in astrophysics. Earlier this year, scientists reported the first ever measurement of the quote, magnetic bridge linking the Milky Way's two nearest galaxies. Known as the Magellanic Bridge, the filament stretches for approximately 75,000 light-years, connecting the large and small Magellanic Clouds. One of the researchers stated, "Not only are entire galaxies magnetic, but the faint, delicate threads joining galaxies are magnetic too. Everywhere we look in the sky, we find magnetism." The lead author of the study stated, "In general, we don't know how such vast magnetic fields are generated, nor how these large-scale magnetic fields affect galaxy formation and evolution. Understanding the role that magnetic fields play in the evolution of galaxies and their environment is a fundamental question in astronomy that remains to be answered." But of course, magnetism is only a part of the story and will always remain mysterious without the recognition of the electric currents required to produce and sustain the magnetic fields. However, we do see increasing signs that this inevitable recognition is beginning to occur. The December 25, 2017 issue of Astronomy and Astrophysics published the paper, "The Jets of Active Galactic Nuclei as Giant Coaxial Cables." In looking at the properties of stupendous parsec-scale jets, the authors conclude that, quote, "Our results have now yielded firm evidence that many, possibly all, active galactic nuclei jets have inward currents along their axes and outward currents in a more extended region surrounding the jets. It also indicates that astrophysical jets are fundamentally electromagnetic structures, which must be borne in mind when interpreting observed features in the distributions of both their intensity and linear polarization." We note the counter-rotating magnetic fields the authors depict in this diagram of the jet's environment. As those in the electric universe community are well aware, the counter-rotation has special significance. In recent years, Dr. Donald Scott has developed the mathematical modeling of a Birkeland current, whose influence can be seen visually in the form of counter-rotating shells, as observed in Earth's cylindrical auroral sheets and at the north poles of the gas giants Saturn and Jupiter. Dr. Scott will discuss the role of Birkeland currents in galactic jets in a forthcoming Space News. Another scientific paper, published in October 2017, also proposes that giant electric currents flow through the galactic jets. The authors state, "Several researchers have reported direct evidence for large-scale electric currents along astrophysical jets. Quite unexpectedly, their directions are not random, as would have been the case if the magnetic field were generated by a magnetohydrodynamic dynamo. Instead, in all kiloparsec scale detections, the inferred electric currents are found to flow away from the galactic nucleus. This unexpected break of symmetry suggests that a battery mechanism is operating around the central black hole." However, we again note the futility of scientists looking to colossal gravity as the cause of stupendous electromagnetic cosmic phenomena. The question is, what can any so-called battery do that is not connected to a circuit? The central object in an active galactic nucleus must be an electromagnetic energy storage circuit element, the aforementioned plasmoid, in a far grander galactic and extragalactic circuit. Plasma cosmologists recognized this decades ago, and was explained accessibly in the book The Big Bang Never Happened. Yet these concepts are nowhere to be found in mainstream astrophysics. leaving working scientists to ponder undeniable electrical phenomena, with little hope of resolving the underlying cause. And so as we enter the new year of 2018, our basis at the Thunderbolts Project for optimism and confidence has never been stronger, as groundbreaking discoveries lead scientists closer to our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info. Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In part one of this presentation, Thunderbolts colleague Andrew Hall began exploring some of the best case studies of electrical scarring on planet Earth. The features don't seem to fit with any standard geological process, but as Hall explained, they do show the expected characteristics produced by electrical discharges. Today, Hall continues his presentation with a focus on the stunning geology in the American Southwest.
In part one of Lightning Scarred Earth, shiprock was presented as an example of a pinnacle created by lightning. Fulgurites are created when lightning strikes, and current penetrates the ground, leaving a hollow tube of glassy, fused material behind. Current from the lightning vaporizes and extracts material in its path, while its heat vitrifies the surrounding soil, leaving behind glassy tubes. Based on its features, it's proposed here that shiprock is a standing fulgurite, created by lightning so powerful and sustained that the material began to recombine in the current as it was pulled from the ground, leaving behind a pinnacle of fused material instead of a hollow tube. Once material recombines, it's no longer charged and attracted to the lightning channel, so is left behind, its ionic makeup altered by the current and heat. The morphology of shiprock displays this very well, with columns of fused rock surrounding an inner core of minette, ionically altered material pulled from the ground by the flow of current. Surrounding the pinnacle are minette dikes radiating away in a star pattern. Minette is high in potassium and low in silica content. It contains high volumes of orthoclase and biotite. Both are minerals with high metal content such as potassium, iron, and sodium. Silica dioxide will readily exchange oxygen with metals such as those found in the orthoclase and biotites when sufficient heat is applied. The prevalence of potassium and other metals crystallize in minette, and its undersaturation of silica is evidence of the reduction taking place as it was formed. This suggests that the lightning forming it was positive lightning, which is the type of powerful lightning seen striking from the stratospheric anvil clouds in thunderstorms. Electrons and negative ions in the ground, pulled out by the positively charged lightning, left behind a concentration of positively charged material which was not attracted and drawn away. The dikes and inner core of the pinnacle show the path of the current being drawn to the lightning discharge. Following the lightning strike that formed the pinnacle, the area was left with a net positive charge, which attracted a secondary ground discharge, or arc blast, that emanated from a different discharge process. This secondary discharge will be explored more in the future, but it's worth mentioning now because it left a magnificent Lichtenberg pattern across the ground, unique to the area immediately surrounding shiprock. The next series of images show the evolution and magnitude of this type of formation. These are all examples from the Four Corners region in northern Arizona. First, when lightning similar in magnitude to what we see today strikes the ground, it sweeps surrounding surface sand to it, drawing it to the lightning channel and creating a shallow crater. Examples of this were shown in part 1, where lightning created small craters with a pile of sand left behind in a small cone. Again, these are not anthills, although they could easily be mistaken for them on cursory examination. There are no ants, no opening in the mound, and it's dusted over the top with sand fused into pebbles. The pebbles rest in a thin layer over the top like sprinkles on an ice cream cone, and beneath it is powder-fine sand. The top layer was formed from sand pulled into the lightning channel and fused into pebbles by heat, then dropped back on top of the mound when the flame extinguished. They bear the same character as the minette material in shiprock center and dike formations. All of the mound material and surrounding sand measures high in pH. The following images show buttes at various stages of growth. The first exhibits an upwelling of minette. The second and third images show the broken remains of the sheath, and the last image shows the dark minette partially surrounded by the lighter rock sheath. Another type of lightning-formed butte has a different morphology that appears to be created by negative cloud-to-ground lightning, the type of lightning that emanates from the belly of a thunderstorm. Because the Earth is generally a negatively charged body, at least in terms of ground charge, it forms a double layer at the interface with the atmosphere. When a thunderstorm forms and the electric field strengthens, positively charged ions in the atmospheric zone of the double layer collect above the ground beneath the storm. Before negative cloud-to-ground lightning strikes, it pulls this material into positive ionic streamers that reach up to connect with the electron avalanche produced by the cloud. When the streamer and avalanche leader connect, a circuit is completed and current discharges through the channel, electrons flowing to ground and positive ions flowing to the clouds. The magnetic field created by the current wraps tightly around the channel, compressing it to a narrow path in what is known as a Z-pinch. Z-pinch has been demonstrated in the lab by simply passing current through an aluminum can with the electrodes connected at the top and bottom. The resulting pinch crushes the can into an hourglass shape. In the huge primordial storms that we theorize occurred in Earth's past, such lightning and pinch effects resulted in huge amounts of positive ionic material being swept to the lightning channel with such extreme force it sometimes created supersonic winds. Fulgamites, formed by sustained giant cloud-to-ground arcs, display the effects of discharging current, accumulation of ionic dust, Z-pinch, and the supersonic winds and shock waves they produced. The images presented show the progression of such an event. First, the strike forms a raised platform with a shallow crater in the center where the lightning created an electrode spot. The rim of the crater is material swept inward by ionic winds and fused. There is a road cutting through the crater in the first image to give some perspective of how large this feature is. These images are from Arizona near Pastora Mountain in the Four Corners region. A more sustained strike begins to accumulate neutralizing material on the spot, forming a flat-top dome like a pancake. As the material accumulates, the pancake grows to a mesa-type structure held together in a round form by the magnetic pinch. In the next phase of growth, the mesa grows taller and the inflow winds begin to reach Mach speeds, creating shock waves that mold the rim material into triangular standing waveforms. A detailed discussion of this shock wave and the triangular buttress formations they create is presented more fully in previous articles on arc blast. As neutralized material builds, the anode spot the lightning connects with is at the top of the mesa and rises with it. The strength of the pitch narrows the top, forming a cone, and new regions of wind-blown, fused, and shock-shaped buttresses form rims outside the older rim. The difference between lightning-formed pinnacles like shiprock and the broad mountain forms shown in these images seems to be polarity in the lightning. This interpretation is preliminary, but it appears that positive lightning burrows into the ground to connect with negative ionic matter beneath the surface, whereas negative lightning attracts surface winds and dust to it to build a mountain. Positive lightning raises a narrow pinnacle of negatively charged material that boils up from the ground with dikes which display the current path through the subsurface. Not much material is drawn to it from the surroundings, except for the sheath of rock it forms around it. Negative lightning connects with pools and streamers of positively charged matter at the surface and pulls huge amounts of airborne dust to create a dome with hardened, buttressed rims. In both cases, mountains can form around them due to ambient winds and blowing dust. Positive arc fulgamites can form monoclines along the dikes if ambient supersonic winds strike them to create a standing wave, where dust piles in long linear ranges of triangular waveforms. The last image above, taken at Comb Ridge Monocline in northern Arizona, shows where fulgamites and dikes are exposed in a monocline. These protrusions create a shock wave in Mach-speed ambient winds that formed a linear standing wave, against which the monocline was formed, like a dune, as blowing dust accumulated. There are several monoclines on the Colorado Plateau that exhibit the same or similar features. Negative arc fulgamites create their own winds, bringing dust to pile against them from all directions, and if powerful enough, form standing shock waves that generate buttresses and a ring around the base. The circular craters and mesas in the images were formed by lightning while the mountain was expanded by windborne dust accumulating around them. There are several examples of mountains with these features in the Four Corners region. Mountains are a misunderstood feature of the planet. Geological concepts are based on rocks forming deep in Earth's crust and being exposed by erosion and tectonic motions, entailing, of course, hundreds of millions of years. It's a very complex process that is not and cannot be witnessed or confirmed by experiment. Mountain formation by wind and electric discharge, however, can be witnessed in nature. Sand dunes are a prime example. Mountains can also be produced in laboratories. So can rock. It happens when slag is produced from welding, ore and metal processing, or from chemical reactions like cement. Atomic and molecular bonding is an electrical process, the exchange and sharing of electrons. Electricity and wind is a far more plausible mechanism for mountain building than what is proposed by the consensus theories, especially since the action of wind and lightning that form mountains on the earth can be seen in any thunderstorm. One only needs to extrapolate the forces and energies involved to what they would have been when Earth was in a much larger, stronger electrical environment. Amplify the electric field of a thunderstorm by orders of magnitude, and it will produce an ionized atmosphere, screaming with supersonic winds, ionized dust, and incredible discharges of lightning that dwarf what we experience today. For examples, we need only to look at our neighboring planets. These conditions exist on Jupiter, Saturn, and Venus. Why would Earth be any different? Thank you.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.
At Kia, we're bringing meaning back to value with America's best value. Value with